Pardon me, I had to sneeze there, so I paused the video. So if we think of taking a snapshot right at the point in time when x is 0.3 and y is 0.4, well, what will we get? Let's do that. So if we take a snapshot of this picture, well, let's just draw the triangle because it's x, y, and z that we're interested in here. I don't need to draw the cars. So we've got x was 0.3 down here. That's the point we care about. So let's put 0.3 for x, and y is 0.4. So we want to know what is the corresponding z value at that point in time. And actually we can get it, right? Because if we know these two sides, well, Pythagoras will tell us what the hypotenuse is. So we can use Pythagoras to get z is going to be equal to the square root of 0.3 squared plus 0.4 squared. And if you work that out, feel free to use a calculator. What you're going to get is 0.5. All right, so what is next? Well, that's the last thing we needed, right? We needed a z value to plug in, and we have everything else. So now it's just a matter of plugging things in. So what we'll get here is 1 over 0.5, and then in the brackets we'll have 0.3, dx dt was negative 50, then y is 0.4, and dy dt was negative 60. So that's what we get if we plug everything in. So now it's just numerical. It's a matter of evaluating the arithmetic. And as usual, I don't have a problem with you using a calculator, but in this case, we can actually work it out by hand. It's not too bad. 1 divided by 0.5 is just 2, right? 1 divided by a half. Here we got 0.3 times 50. Well, 3 times 50 would be 150, but it's only 0.3, not 3. So it's only going to be 15. But the 50 is negative, so we're going to get negative 15. 0.4 times 60. Well, 4 times 60 would be 240. So 0.4 times 60 is going to be 24. And since the 60 is negative, we'll have minus 24. And then that cleans up pretty nicely. You really just have 2 times, what is this going to be? This will be negative 39, which is negative, or when you multiply it by 2, you get negative 78. So that's the answer to the question. dz dt is equal to negative 78. That tells us how fast the cars are approaching each other. They're approaching each other at 78 miles per hour. Why is it negative? Why was our answer negative? Well, just like for the same reason that dx dt and dy dt were negative, because x and y are shrinking quantities. As the cars approach the intersection, x and y are shrinking quantities, but so is z. So you're expecting to get a negative value for dz dt. So that confirms, or that's corroborated by reality. So let's summarize our answer. So the cars approach each other at 78 miles per hour. So that's how you can solve problems like that. And again, this problem really emphasizes the importance of interpreting the sign of a rate of change correctly. If your rates of change for a variable are positive, that means the variable is growing over time. If the rate of change is negative, that means the variable is shrinking over time.